Okay. Once again, let me continue with settlement of foundation, and that too I have mentioned that the foundation settlement total settlement may consist of three parts. One is immediate settlement, consolidation settlement, and secondary compression. And we are now discussing on immediate or elastic settlement, and for different shape of footing on different soil. If it is a infinitely homogeneous soil layer, then how to find out the settlement I have just mentioned, but the soil, and that is comparatively easy, single formula, and only if you know the width of the footing and soils Young's modulus and Poisson ratio, then we will be able to find out the settlement. But the actual field condition may not be homogeneous up to the infinite depth or up to large depth. In fact, below the footing quite often will have multiple layers, and when this multiple layers footing rests on multiple layer of soil, then actually how to find out the settlement. So, we have discussed Smartman methods in the previous lecture, and we have given two models. One is for actually strip footing, and another model for square and circular footing. And using these two model, how to find out the settlement I have discussed also, but let me take one problem to explain the how this method can be used. And let me go to this problem. The problem is given here, but before going to the problem, let me take some time to explain how to use this equation. So, equation was the initially the model was something like this. Suppose so, this is the model. This is either this depth, suppose if it is a strip, it will be 4b, and similarly this will be b, and this will be your 0.2 considering strip, and this is actually I epsilon max. Now, but our expression for settlement is delta equal to C 1 C 2 Q effective, and then sigma I epsilon I H I divided by E I. So, equation is like that. So, how to apply this equation? So, suppose I imagine the soil has two layers. One layer is this and another layer up to some depth, but I need not go up to that depth. What I have to do? I have to find out settlement for this layer and settlement for this layer up to this depth. So, how I can find out this? This equation can be written slightly different ways, like you can see now. So, this is a area, it is little two trapezium actually, this is one trapezium and this is another trapezium, this area coming under one soil, but your expression can be written something like this: C 1 C 2 Q effective, and I can write I epsilon 1 H 1 divided by E 1 plus I epsilon I epsilon 2 H 2 divided by E 2. I can write the equation in this form. So, when it is two layer, I can write equation like this. This is this summation, removing this summation, I can write this. Now, I have to find out what I E 1, that means influence factor for the layer 1, and I E 2 influence factor for layer 2 I have to find out. Now, you can see this is a area variation is there. So, there is not a one value, that is a irregular shape, and this is a triangular shape. Okay. So, they have also different point, different I value. So, how to find out this one? So, that means the I may vary over depth, but it is varying linearly. So, because of that I can take the average. So, suppose this one, this is a triangular area. So, triangular area at the middle of the, so I can take the half. What is the value at the base and at the 0? So, at the middle it will be definitely half. So, that means what concept we are using? Concept actually using to find out the average influence factor. I can think of finding out the area divided by the depth. So, half multiplied by base multiplied by height, this is area, and divided by height. So, it will become b by 2. That means, whatever the value here, half of that can be taken for IE for second layer. But for first layer, how to find out the IE? Here actually, since irregular, I can divide again first layer into two parts. This is one part and this is one part and this is another part. So, I can write this first part, I can write IE 11 by E1 H 11 plus IE 12 multiplied by H 12 divided by E 2. That means, what I have done, this is again E 1 because same layer. So, what I will find out IE 11 and IE 12. That means, I have to find out average of the average I here and average I from here. So, for that what I need, this maximum value is known. So, I know this distance and I know the layer position, then from the symmetric triangle I can find out this value. From the symmetric triangle I can find out this value. Once I know this value, I know this, I know this, I know this. So, now what I will find out, this is a trapezoidal area I 11, I E 11, I will find out this one, this is suppose I 0 I say plus I E max divided by this plus this divided by 2, then it will be average, is it not? So, so half multiplied by this multiplied by height is the area, and area divided by the depth I will get the average. So, this is the value of I E 1. Similarly, I epsilon 1 2 will be I E max plus this value, suppose I E of I epsilon, which to be determined from the symmetric triangle divided by 2. So, that means, since I have this equation, now since two layers I can write in two components I E 1 and I E 2, and when in the zone 1 if the two different areas are there irregular, then again I can find out two areas are there. So, I can find out I E into two parts I E 11, I E 12. So, for that actually what I will do, I will find out this first and these all three are known. So, I will be doing I E 1 can be obtained this way, I E 12 can be obtained this way, then finally substitute here and I know what is the height here, what is the height here. So, multiplied by this and this, then I will get the ultimately component for first one and then second one. So, like that I will add and that multiplied by this I will get the total settlement of the footing on resting on this two layered soil. If it is any number of layers, suppose in between there are number of layers, then you have to divide more number of pieces, this triangular area and this area into more number of parts. So, that is the thing I will try to show by this problem. So, this is the one, this is the problem actually you can see now. It has a foundation 1.5 meter square, that means square foundation will carry a load of 300 kilonewton per meter square and will be. So, that means 300, that means your sorry. So, that means your square footing B become 1.5 and your QS become 300 and will be founded at a depth of 1 meter. So, D equal to 1 and the soil's unit weight is gamma equal to 20 kilonewton per meter cube and the approximate N to Z relationship is shown in figure. How I will talk about that. Actually, instead of giving E value can be correlated with N value, that is SPT number, which we will discuss later on. So, N is the SPT blow count. For this layer it was 12, for this layer it was 16, for this layer it is 24. A relationship with E, relationship with N to E is given here, E equal to 1 multiplied by N in meganewton per meter square. That is ultimately that first layer E will be equal to 12 meganewton per meter square, second layer it is 16 meganewton per meter square and third layer it is 24 meganewton per meter square. So, this is the situation given. So, for this I have to find out the settlement. Okay. So, for that let me see one by one. Suppose your ground surface is somewhere here and your footing is at 1 meter depth. Suppose footing is at this depth. So, that means your diagram will start from here and since it is a square footing, the value here actually 0.1 and since it is square footing, it will be B by 2, maximum will be at B by 2 and so that will be somewhere this and maximum will be at 2 B depth. So, this. So, diagram will be something like this and this is 1 meter, first layer is 1 meter and second layer will be, now first layer will be this is depth of foundation, your first layer actually up to 1.75 meter and since it is B by 2, B is 1.5, this is also 0.75. So, because of that it is coinciding. So, first layer and IE max, that is IE max at the same level and then second layer is at 1 meter below, this is again 1 meter and this is actually again that will become 1.25. Okay. So, this layer is extended beyond that, but I will take settlement up to this. So, this is the diagram now. So, you will have Q effective will be 300 minus 1 multiplied 20. So, it will be 280 and you will be having sigma B dash or it is sigma B by 2 dash actually, sigma B by 2 dash that will be equal to will be 1.75 multiplied by 20. So, that will be equal to 35 kilonewton per meter square and IE max, I epsilon max will be equal to 0.5 plus 0.1 under root Q effective is here 280 and sigma b by 2 dash, that is 35. So, that gives you 0.783. So, this value is 0.783 and if I know the distance, so I can find out I e, suppose this layer. So, this I e I can find out from the symmetric triangle. So, I epsilon divided by 0.783. So, this is 0.783, this value is 0.783. So, I 0.783 will be equal to 1.25. So, this side is 1.25 divided by the entire height, that is 2.25. So, from there I will get I epsilon will be equal to 0.435. So, now I have to find out the total settlement, and for total settlement I need, that means I have to find out for this layer, I have to find out for this layer, I have to find out for this layer. So, 3 parts, there will be 3 parts. So, I epsilon 1 will be how much? So, I know 0.1 here and 0.783. So, it will be 0.1 plus 0.783 divided by 2, that will be equal to your 0.44, and I epsilon 2 will be equal to, you can see this plus this by 2. So, this will be 0.783 plus this one is 0.435, 0.435 divided by 2, that will be equal to actually your 0.609, and I epsilon 3 will become the half of this, that means 0.435 divided by 2, and that will be 0.2175. So, we have got this. Now, you have to find out C 1. C 1 actually your C 1 equal to 1 minus 0.5 multiplied by Q s by Q effective, that Q s by Q effective, that means 1 minus 0.5 multiplied by 300 divided by 280, and that gives you 0.46. And C 2 actually it is mentioned after 6 months. So, it will be 1 plus 0.2 log 0.5 multiplied by 10, and if I do this, then you will get 1.14. Then your delta become 0.46 multiplied by 1.14 multiplied by 280, that is outside of the expression, and this will be 3 components. So, I e 1 will be 0.44 divided by, it is 12 multiplied by 10 to the power 6 and plus second one is 0.609 divided by the, it was 16 multiplied by 10 to the power 6 plus the last one is 0.2175 divided by 24 multiplied by 10 to the power 6, and this is 10 to the power 6 Newton per meter square. This was a kilonewton. So, for that I can multiply by 10 cube, and then I can multiply for to express in millimeter another 10 cube. So, this will get cancelled. So, it will be expressed in millimeter, and if I simplify this entire thing, then finally, we will get settlement equal to total settlement will be equal to 12.3 millimeter. Okay. So, this is the one. So, everything I have shown here very clearly, I hope. You can see that the footing is placed at 1 meter. So, this is the ground mark, but this is the footing level, and first layer is up to 1.75 meter, and since it is a square footing, then is influence factor will become maximum at b by 2 from the base of the footing. So, base of the footing is this and b by 2 is 0.75. So, this depth become 0.75. So, that means that total depth from the surface, that I max become at 1.75 meter depth, and this is the depth of first layer also. That means, depth of first layer and the I max is coinciding. So, beyond that I will not consider, but from here I will be considering. Then I E max, actually there is a expression for that. Actually we have I E max actually 0.5 plus 0.1 under root Q effective by sigma b by 2 dash. So, for that Q effective I have calculated, sigma b by 2 effective I calculated, and use this expression I have got the I maximum. Once I have got the I maximum, so I have put here, and then I know that for square footing and circular footing the strain becomes 0 at a depth 2b depth. So, 2b from base means how much it will be? It will be 3 meter. So, you can see this is 0.75, this is 1. So, 1.75 and then this will be 1.25, and so from the first layer second layer thickness is 1 meter. So, 1.75 to 2.75 is the first layer, and the third layer is extending beyond, but I will be considering from 2.75 to 3 meter depth. Okay. So, this is the thing 3 meter from the base of the footing. So, this is taken. So, once I know this value and this value, then what I have to find out? I have to find out now I influence factor of this layer, influence factor of this layer and influence factor of this layer. So, to find out the influence factor of this layer, what I need to find out? I need to find out this value. How to find out this value? I can consider this triangle and this triangle. From this symmetric triangle I can express this, and from there I can find out I E, that is 0.435. Okay. So, this is known. Now, once I know this one, then what is the average value of I of this layer? Half of that is shown here, and then what is the average value of I for this layer? This will be just summation of half of summation of this and this multiplied by 0.5. So, that is the thing is done, and what is the average value of this? That is half of this summation, half of summation of this and this. So, that is done here. So, once I get I E 1, I E 2, I E 3, and then total expression of settlement, that is your delta equal to C 1, C 2, Q effective multiplied by sigma I epsilon I divided by E I multiplied by H I. So, sorry, I have not multiplied by H here, respective H. So, it will be here multiplied by 0.75, here it will be multiplied by 1, and here it will be multiplied by 1.25, that will be also there. So, I missed that one. So, and if you multiply by that, the value may come little different, that has to be checked. So, I think I do not have calculator now. So, this will be multiplied by 0.75, this will be multiplied by 1 and this will be multiplied by 1.25. The value by and large will come same, because it is 0.75 is close, this is 1 will be unchanged, and this is 1.25, this and this will be balanced. So, value will come close to this, but I missed this one, it has to be multiplied by thickness. So, I have not done that. Here also multiplied by thickness, here also it will be multiplied by thickness. So, if I do all those things, then I will get a value something close to that 12.3. So, these are the steps actually finally to be used for calculation of elastic settlement using Smartman method. So, as I have told that the circular footing, the different shape of footing, and you know that circular footing q b 1 minus mu square by E delta multiplied by I, and I equal to 1 for circular footing maximum. So, when there is, so instead of remembering different number, different I value, what I can do sometime, actually if the footing is rectangular or something else, suppose rectangular footing, a rectangular footing L and L and this is B, and L by B equal to suppose 5. So, this footing actually can be converted to an equivalent footing. Suppose the I can consider as pi r square equal to B multiplied by 5 B. So, your R become 5 B square by under root 5 by. So, R actually, so this this rectangular area can be imagined by an equivalent circular area. How actually R can be expressed under root 5 by pi multiplied by B. So, this is the way if I R is expressed, and then simply use this equation, and then that means circular only one equation can be remembered, and for that what is the I value if I remember, and any shape like rectangle with different aspect ratio like this L by B equal to 5, then I can express pi r square equal to B into 5 B, and then R become this. So, if I use this R here instead of R equal to 2 B, so I can put here and only use equivalent circle equation. So, circular foundation equation, and the result will be by and large similar, only maybe 5% error. So, sometime whatever table I have shown for different shape of footing and different aspect ratio, the different I value to be remembered, instead of that I can remember the value of circular footing, and when if it is a non-circular footing I can convert into equivalent circle and use the equation of circular footing settlement. So, that sometime quickly one can do it without remembering the detailed table. So, with this I will close here. Thank you.